I would like to invite our next speaker, Mr. Sarangapani, AGM in Project Engineering C&I Department, NTPC. Sarangapani has 27 years experience in power plant C&I engineering. His exclusive focus areas include HMI engineering, third-party interfacing, and OPC. I request him on the stage.
First of all, I should thank ARC for providing me this opportunity. The topic of my presentation is transformational changes in automation systems. Now, as you see, there are so many new topics like IoT and so many things talked about. Now, what are the real changes in the automation systems to gear up to these challenges? So those I will be describing. My agenda will be this about automation systems, the history, then what are the new innovations we have done, and mostly I'll be concentrating on the cases which we did in NTPC, and they'll be basically the success stories, and they'll be all related to the concepts which we heard in the morning. A brief about NTPC, and as you know, a leading power major, top performer, trusted technology partner, and caring for the planet. Now the new buzzwords are solar and wind, and that's nowadays the thrust is on solar, and out of which the installed capacity, if you see, 200 megawatt is of solar, and 560 megawatt of solar is under construction. Now coming to the automation systems. The journey of DCS in NTPC I have just captured in different stages, and I call them 1.1, 1.2 and so on. Earlier we had the relay-based systems, which only DAS was the only microprocessor-based system in the plant. Then we had the DDCMIs installed, where the operation was through the CRT devices. And also for the traditional boiler and turbine controls, we had microprocessor-based systems. And then the electrical breakers were also made part of the DDCMIs. Then we had large video screens for operation. And then from Talcher onwards, we had the offsite areas information coming in the control room. So more and more information coming into the control room. And maybe the last stage of the previous the developments, that is the offsite area controls also being on DCS. Now the basic criteria on which the automation systems are built are these: the availability, efficiency, reliability and safety, not in that same order. And these are the key performance areas on which any automation system has to fulfill. Now I present the innovation suits. As you know that this year's theme of the ARC forum is navigating the new age of innovation. So we are talking about innovations. So what are the innovations in the automation system? These are centered around the same previous basic criteria. So these are basically taking the automation system to a different orbit. And the reason, that's the reason I call it Automation System 2, because the earlier developments were, that I call is 1.1, 1.2, they were on a different scale, but this is taking it to a different orbit. And these are basically the new connectivity and connectivity, the widespread integration, the result of all these things. And why they are called arranged in a circle is, the reason, there's a specific reason that widespread connectivity causes coherence and integration among systems. And when you have integration among systems, the plus points of one system gets benefited to the other system, like an enterprise level software, a software on the cloud, which can be, the results of that can be shared by the automation system in the control room. So the operator has a benefit of all the analytics, the powerful software on the cloud. Of course, as the previous speaker had mentioned, that all this connectivity has got the flip side, which is the cybersecurity, and this security, enhanced security is part of the automation system. And that's how, and some of the security concerns, maybe the previous operating system like Windows XP is solved to some extent by virtualization. So that's the reason of a circle. And now there could be more, such innovative topics, but I have chosen 4 because these have been applied in NTPC with some case studies. I will be presenting the case studies. So the first study, the case discussion I'm presenting is enhanced connectivity, how it led to the concept of unified HMI. Now there's the same picture which Andy Chetta presentation at Orlando had seen, that is this connectivity, the same picture I have drawn. So you have connected enterprise, the connected services, connected products, connected operations, connected workers, and connected supply chain. So there's one buzzword which can describe the information-driven enterprise of today is connectivity. Increased connectivity has, how this increased connectivity has affected the automation system, the DCS, that is through interoperability. And this interoperability concept had led to the unified HMI. So interoperable means whether a DCS can be operated from the other DCS. More precisely that it can be from the HMI of another DCS, whether a DCS can be operated. The answer is yes. How? Let's see. This is the unified HMI concept, which is a result of increased connectivity among systems. Traditionally, the control system of any DCS is operated by its own HMI. And that's how the systems have been engineered till now. But whether it can be operated by the HMI of another DCS through increased connectivity, enhanced connectivity, and that is possible, where you suppose this is the DCS, which is traditionally operated by its own HMI, but we want it to be operated by the HMI of another DCS, and this is the type of unified HMI concept which is being thought of. And the HMI of DCS is sending commands to the control system of its own control system, and through Modbus links, the entire command is transferred to the control system of DCS-Y. So what happens, all the points of DCS-Y is transferred to DCS-X, and it becomes a part of the database of the HMI-X. So the HMI-X becomes the master, and you don't have the HMI of DCS-Y at all used. That's a native HMI of it, and it's not used. It's kept in the programmer. So this type of connectivity, where you have one DCS getting operated by this, is the unified HMI concept. But let's see why this concept is needed. If you have, that in a power plant, in the main plant, if you have a single package, a PC package or a turnkey plan, you could have one DCS operating the entire main plant. If you have one DCS, then you have one HMI. So there's no need of a DCS X or Y. But most of the cases, what we found, that there are 3 packages for the main plant. One is the boiler package, the SZ package, then the turbine package, and also the BOP, the main plant BOP or the session C&I. So when you have 3 DCS for the 3 packages, because of different contractors, different DCS, then you have 3 HMI. And the operator has to operate the plant through 3 GUIs in the main plant. So if you, like for example, if you have a mill startup and shutdown, you need to do it from the SD HMI. But the same mill, if you want to do the temperature controls or the flow control, you have to use this HMI, which is have a different GUI altogether. Same equipment but different GUI, it becomes a problem for the operator. And in one of the seminars, the operator persons were telling that please don't give this. We need, a car should have only one steering. Multiple steering means we get confused. And that is the reason for, if you have enhanced connectivity between systems, we should give one single unified interface to the operator, be it different systems in the plant. So that is the result of how the enhanced connectivity had led to the concept of a unified HMI. Now, this unified HMI has already been implemented at our MODA stage 2. In case of the TG package of 660 megawatt in some OEMs, within the same package, you had two different DCS, one for the integral controls and one for the balance of the TG package. And in that, we had two DCS in MODA, in the TG package, one by Siemens for the integral controls and other by Max DNA, the main package supplier. And the scheme was discussed extensively between BHEL, Siemens and NTPC. All the signals of Siemens system are transferred to the BHEL system. And the native HMIs of the Siemens system, as you see, the DCS-Y is kept separately in a programmer room. The scheme was extensively tested at Siemens Germany. And I remember that there were two important parameters during the testing. One was that due to different HMI, the latency, the response time, which normally is possible with the native HMI, should not get disturbed. The same latency we maintained, we could get that response time, and the redundancy of the links. So whatever in the native HMI, the redundancies which are possible, the same redundancies we could get with this. And in the commissioning, this was ensured that it is commissioned from the unified HMI. Because the habits which are formed during initial stage of the plant, they are very difficult to remove. And that goes on through the entire plant. So that is the reason we ensured that this TG system is commissioned by the unified HMI only, and not from the native HMI. And encouraged by this success of this particular unified HMI in the TG package itself, now we have specified for all future projects in the EPC package that we should have a single HMI for the main plant. And today the EPC scenario is that we have two EPCs, SG and TG. And the SG is made the master. And all the commands, all the drives of TG will be operated by SG. Now the next topic, of course, I need not dwell much about it. My previous speaker has covered most of the things. But still I'll see that I'll discuss some of the cases in NTPC, what are cybersecurity measures we have taken. The concerns, the cybersecurity, some of these incidences, Stuxnet was discussed, Ukraine was discussed, I need not dwell much about it. The most important in Stuxnet in Iran, when the centrifuges were operated, was the operators were not aware that this is operated. On the faceplate of the centrifuge, they are still seeing the old status. So this is an example of a targeted attack. The targeted attack will not ever make you know that there is an attack going on. Ukraine also, it was simple. It was a multi-factored attack, sophisticated multi-layer attack. Okay. And then the most important in such attacks is that production downtimes is not only production downtime, but can compromise on human safety and machine equipment safety. So one of the questions in the forums page, ARC web page was, will cybersecurity concerns impede disruptive innovation? Because in the morning, you see, there was always a series of presentations about IoT, connectivity. Only the last presentation, people were slightly thinking, because of the last speaker, that the cybersecurity concerns, will it impede? But the answer is that innovations now should be inclusive of cybersecurity. Like a concept of what is the safest house? If I ask, the safest house, as you say, is one which doesn't have any door, any window. But that doesn't mean we construct house without doors and windows. So that is the same point I want to make, that if for fear of cyber threats, we cannot stop the innovations. The innovations must go on. And that is the reason that security, as Andy Chetta was also mentioned in the morning presentation or video, that security has to be built in. And today that security is built in because of standards. It is not that I should have better security than this. This is the minimum security which is mandated by standards. And earlier the standards were only ISO standard for the IT. Now for industrial control system itself, there is a standard, the IEC standard which has come. And similar standard is coming for the power sector specifically for India. And I'm fortunate that as part of both the standards, in the preparation of both the standards. And one of the concepts which is mandated by the IEC standard is If you see the concept of the safety integrated level for the safety purpose, the similar concept has come for security, that is security assurance level. So there also, as you see right on the right, that these are the levels of SAL, security assurance level. And most security you get from the SAL 4. And basically the levels are basically graded so that security is fit for purpose. For a power plant or a power utility, you may have higher security, but maybe for other small plants, it may not be so required. So there is a gradation of security here. DCS security is a must-have now. And just a brief on the cybersecurity measures in NTPC we had. The various architecture, one is the concept of design, one is the people aspect, which is the policies and procedures, and the third is the compliance of the same through audits. This was undertaken about almost 10 years. In fact, incidentally, one of the persons with whom we worked is present here during that time when the consultancy on CMC was there, Mr. Sengupta. So, in those days also we worked out the architecture with a multiple defense of depth layer. So which means we had a DMZ zone, the requirement of not having the same protocol being repeated from the connectivity. There are many small things in the architecture. Next I'll come, because I have only 10 minutes left. Another concept of lifecycle management. Now the DCS employs a lot of computers, each computer traditionally doing a particular function. And because of the number of computers, if you see the actual duty cycle of a computer for a DCS, it is actually very less. The resource utilization is very less. And because of the number of computers, the footprint is large. And another thing which is also a problem with lifecycle management is obsolescence. And the particular thing is the software obsolescence, the operating system patches, which basically stop, and then you don't have these security upgradation for that. And another issue with the lifecycle management is that every new platform, the hardware changes. There are many things which are specific to the drivers related to the hardware, and those also changes. So development efforts also increases every time the new hardware platform comes. So these are some of the lifecycle management issues of DCS. How these are mitigated? The answer is virtualization. Virtualization as a concept is that you have a hardware, and then you normally have an operating system which is managing the hardware resources, and you have an application on top of them. This is the traditional architecture. In virtual architecture, you have a hypervisor doing everything, and you have multiple instances of machines, the OS as well as the applications running on the same hardware. So basically, utilizing the resources of the physical computer. The same concept is with VMware also. That was with the hypervisor, which is a Microsoft product. Then what all the experience of virtualization in NTPC? Many of our sites have virtualized the DCS at various stations and taken the benefit. And and for the Siemens case is basically as per design. The Siemens system itself has got the servers and the workstations and even the controllers which are virtualized. So the expectation from, since the end user being at site, we have virtualized it, and basically we have done a machine and then added VMware or hypervisor. The expectation is that each DCS vendor should standardize the design in virtual environment and validate the work at our sites. Because virtualization, sooner or later, all DCS vendors will embrace this technology for the benefits. And what are the benefits? Let us see. Platform independent, as I already told, because development efforts are free of hardware layer interfaces, less footprint definitely, and then faster restoration because it's all virtualized, it's only a file, and the most viable solution to OS obsolescence. If you have Windows patches not available and your XP machine, most of the traditional approach is to change the hardware, change the OS, and change the HMI also. Because if you change the OS, the HMI also changes. The application also changes. and that application change is to the OEM. But then here, if I change the hardware, I install only a new machine, new operating system, and I virtualize the old application. So by having virtualization, I'm extending the life of my existing infrastructure or existing investment over much more period than the normal which is operated given by the operating system. So this is one way of extending the line and to overcome obsolescence of software. And the next part is data analytics. As already mentioned in the morning, that the layer between automation system and enterprise system is getting thinner. You have the cloud. If you go by the definition of a private data center also being a cloud, then it's like I think I should call this also a cloud. It's an NTPC cloud, where the data is coming to a centralized monitoring center, and your operators doing the analysis, and then you are basically trying to drill down diagnostics, where you can see that where is the problem, and such type of softwares which are there in the enterprise, those basically are able to give an early warning, and the early warning can be given back to as a web client to the site. So the power of data analytics can be used at the control room. And one of the, I'll just describe briefly one of the data analytics part in a detail, that is advanced pattern recognition, where normally the DCS alarm, it's a very high limit, but if you see the patterns, you have a basically close relation of parameters for any equipment. And when you, in a normal behavior, you try to capture the correlations between parameters and develop a model. And from that model, when you deploy in actual deployment, you see you get an expected value for each parameter. And this expected value, when it differs from the actual value by something greater than the amount, you get an alarm. And that alarm, that alert, which you get is much before the DCS alarm. Once you get an early warning, which is much before the DCS alarm, you have basically a big window for operation. And that is one of the approaches which was told was a predictive maintenance is for the maintenance angle. But what I am carrying forward is a different application here, that through the early warning, one can also improve the alarm management of the system. Normal alarming, DCS alarming is fixed alarm through the OEM, and it's a reactive approach, because once the alarm is reached, operator is flooded with lot of alarms. In a power plant, one disturbance has a spiraling effect on many other parameters, and immediately you get a lot of alarms. And it is not possible, humanly possible, to tackle all these alarms together. So if you have an early warning much before, your alarm management in the control room is improving. There could be many such cases of where enterprise level software, the power of data analytics, the power of predictive analytics at the enterprise level is helping back the automation system. Because of the higher connectivity, the automation system should get benefit of such powerful software and use it for the day-to-day functions of the DCS, alarm management being one important function of HMI. Now the road ahead, as already mentioned in the morning, IoT, cloud computing, mobile service apps, and service-oriented architecture, SOA. So cloud computing, I can say that recently CPCB has mandated that all the environment data, the ambient air quality data, then effluent data, and even the emissions data, all should be available on their cloud. And this is the already work we have started to populating their cloud, and through a separate channel, not through the DCS channel. So cloud is getting very popular, and in fact this has to happen because the power of cloud computing has to percolate back to the automation system. Automation system will have to receptive about getting all these results from the cloud computing. And so I conclude, I'm still within time. And as I say, the technology adoption in a power plant or in even a petrochemical plant, large gestation period is there. By the time you specify and by the time the technology is actually deployed, it's almost sometimes 3 to 4 years. So it is very important that we adopt technology very fast. Sooner we do, it is better. It will reap the benefit. Another thing is that since this problem is there for the last gestation period, we should adopt more and more pilot projects, because once you have a pilot project, we get the benefit of technology and we can adopt it very fast. And the third is that disruptive technologies will continue to will radically transform the automation system, especially in the field of HMI. And to end, I end with the quote: to improve is to change, to be perfect is to change often. And at the end, I want to thank Mrs. Arundhati Bhattacharya also for the constant support and encouragement for the adoption of these technologies in NTPC, and the belief that these technologies and the persons who are handling the technology will work. And I also thank the audience for the patient listening. Thanks a lot.